Okay, in this video, we're going to be talking about the difference between SetTimeout and promises. And specifically, we're going to be talking about the differences and how they relate to the event loop. And I think that this is an important conversation to have, even if you are familiar with SetTimeout syntax and promise syntax, and even if you've had a conversation about the event loop. I think that this is still an important topic to discuss because by looking at these differences, we get a much better understanding of how the event loop actually works and kind of the behind the scenes processes. And this is such an important part of JavaScript that I think revisiting it, even if you visited it before, is always helpful. Okay, so without going much farther, let's stop and make sure we're on the same page. JavaScript is a single-threaded synchronous language. And what does that mean? Well, single-threaded means that you can do one thing at a time. And it's hard, I think, for humans to understand what single-threaded is because we're such multitaskers, right? We constantly are doing numerous things at a time. We're drinking coffee and on the computer, we're driving and talking on our phones. Hopefully you're not. This concept of doing one thing at a time just isn't normal for us. However, I think, and I'm taking this from Jake Archibald he's a developer advocate for Chrome. He says the only time that humans are actually single-threaded is when they sneeze. And I couldn't agree with him more. I mean, think about the last time you sneeze. If you were driving, you probably just prayed quickly that no car would jump in front of you. And if you maybe were talking to a friend, you probably stopped talking to a friend. Whenever you sneeze, you become single-threaded, right? You can't do anything else. Okay, so JavaScript is single-threaded. Now, what does asynchronous or synchronous mean? Synchronous, the opposite of synchronous is asynchronous. And I've heard numerous definitions that are trying to describe what these terms mean. And honestly, the only one that's ever stuck with me is one that comes from Stack Overflow. And it talks about how, let's say it's Friday night and your plans are to make pizza and then to play solitaire. And so what do? You start making the pizza. All you're doing is making the pizza. And then once you finish, you can go and play solitaire. Okay, that's synchronous. Well, in an async version of this, you get smart and you say, I'm going to order pizza. So you order pizza and then while the pizza is being made, you go and you do other things. Maybe you start your solitaire game. But the point is you fired off an event and something's now happening that you aren't really worried about right now. And then later on, once the pizza's made, you get a knock at the door and your pizza's been delivered and now you can eat it. And then you can go and you can play solitaire. So this concept between async versus synchronous, where synchronous, you do one thing at a time and they're kind of in this synchronous order. Async is you've kind of changed the order of things, right? You've actually had someone else go make your pizza and then you're not worrying about it. You're doing other things. And then when it's done, you are made aware that the pizza's done by someone knocking on your door, and then you can kind of go about your business. So JavaScript is synchronous and it's single-threaded. Okay, great. So now let's go and let's talk about the event loop. And I've seen different diagrams for this, but the one that kind of is most familiar to me is this one where you've got this heap and you've got this stack and you've got this queue. And the heap is just a placeholder for memory. So we're not going to worry about that because we're not going to talk about that much, but just know that that's what that means. And in fact, I'm going to delete the stack and the queue as well because I want to draw them differently. Okay, so here I've got my queue on the right and I've got my stack on the left. And the queue, there's so much terminology around this and it's unfortunate because this is already kind of a complex topic, but the queue can often be called like the task queue or the job queue or maybe even like a message queue. And these terms come from the different specs that are referring to them. So the job queue is the JavaScript spec. That's what calls that queue the job queue. But the HTML spec will call it the task queue. So I'm just going to call it the queue, but I am going to say tasks when I'm referring to things that go inside of it. Okay, and then over here, the stack is the JavaScript stack. This is what's processing the JavaScript. And then in the background, you have this event loop. And the event loop is constantly running. Super, super fast, and it takes in tasks, and then it has this JavaScript stack process them, and while the JavaScript stack is processing these tasks, the event loop isn't taking any other tasks. So other things that the event loop would be taking in, while it's not processing JavaScript is things like updating the DOM or rendering images, all the things that browsers like to do that are not something that we tell it to do. Okay, so before we go forward, I also want to clarify that the queue processes things first in, first out. And the stack, JavaScript stack, processes things last in, first out. And what does that mean? Well, last in, first out is what we think it means. So like what we think a queue behaves like. So if you have like a line of people waiting for coffee, the first person in line is the first person to get their coffee. The second person is the next person, and so forth. So first in, first person in the line gives the first cup of coffee, first in, first out. And what about last in, first out? Well, the analogy that's always given here is one with dirty dishes. And I like this analogy, so we're going to stick with it. All right, so let's pretend you have a stack of dirty dishes. And then over in this other pile, you've got dishes to be cleaned, right? And you put one dish over into the clean pile, and then you put your next, and then your next. And the last dish that you put into your clean pile is the one that you're going to be cleaning first. So last dish in, first one out, right? So that's how last in, first out works. Okay, so just keep that in mind as we're kind of going through. Okay, so how do we get things into the queue? You attach a function to an event. So what are events? Things like window reload or button clicks. All the things that you do to fire off JavaScript, those are events. And as long as you have a function attached to them, that's going to fire something off into the event queue or into the task queue. I'll just call it the queue. Okay, so then what happens? Well, the JavaScript stack is always waiting for things to come to it. So if it's empty, it's asking the queue for the next thing to process. So it's like, I'm bored, and the queue is like, okay, I'll send you something. So the queue sends the first in line, right? Remember, first in, first out, first task over to the JavaScript stack. And then the JavaScript stack is where the JavaScript gets processed. And in the background here, what's happening is this event loop's turning around. It's going really fast. It now just picked up a task because the queue sent it over the JavaScript stack. And while the JavaScript stack is processing this JavaScript, the event loop can't pick up any other tasks. So it can't pick up things like updating the DOM or rendering an image or things like that. Okay, and then once the JavaScript stack is done processing something, it clears it and it asks for the next task from the queue. Okay, so let's see this in action. Let's pretend we have a button over here and we have an on click. We fire off function 1, and function 1 looks like this. It says console log A, console log B. Okay, so we fire off this button click, and now we've got a task inside the queue. The stack is empty, so we send over the task over to the queue. We send the task over to the JavaScript stack. Okay, and now we start processing this. So we read it from top to bottom, and it says console log A. All right, so we have A, and then we have console log B. And then remember, first in, first out for the JavaScript stack. So over here, I have my like fake browser console, and this is going to read like console log A, console log B. Okay, great. Now we clear out the JavaScript stack, and there's nothing left in the queue. Okay, great. So that's kind of the process. And I'll show the code examples at the end of this. Okay, so now we're going to make sure that what we showed in the drawing actually occurs. So on the right-hand side, you can see I have example 1, which was console log A and console log B. And then you can see I've got this button here that fires on click function 1, and function 1's there. I'm connecting JavaScript through this script tag down here. Okay, so just to double check my work, click me, and I get A and B. Okay, great. Now let's go over and try with a SetTimeout function in the function 1. Okay, now that we're back into the drawing, let's look what happens when we add a SetTimeout inside of our function 1. So we're going to move our console log B down, and we're just going to slip in SetTimeout here. And we're not going to worry about adding a specific time that we want to delay this action. That's not what we're focused on here. That's a topic for another video, but what we're concerned about is how SetTimeout gets processed versus how promises get processed. And I want to take a moment here and stop and just remind folks that SetTimeout is not native JavaScript. And maybe this isn't a reminder, maybe this is brand new information to you. It was for me when I heard this. And it's important to keep that in mind because the way that we're accessing SetTimeout is actually through an API via the browser. And because of that, it has different implications on how it's processed. So just kind of know that. If you want to find more information about that, I'd encourage you to look up W3 documentation on SetTimeout. It links you to the window object, which is an API that we have access to via the browser. Other methods that are on the window object include things like the console or setting things to your local memory. Okay, so with that aside, let's continue on. And we're going to walk through this just like we did with the previous function. We're going to see what happens. So let's pretend we have a button click. We click the button, fire off a task, and the stack is empty. So we're going to move that task over into the stack. And then the JavaScript stack now starts to process this function. And so it first gets to console log A, which we see, we put there. And then it gets to SetTimeout. And here's where SetTimeout is different than promises. And it's different in a lot of ways, but here in relation to what we're talking about, here's the big difference. SetTimeout actually fires off another task. So that task doesn't immediately get processed in the stack, in the JavaScript stack. It actually leaves and sets another task onto the queue. So it goes to the back of the queue and stays there until it has its turn and it's ready to be processed by the stack. So let's go ahead and make that task. And then let's keep processing. And we see console log C. So we put that there. So then our console output ends up being A and C. We clear our stack. And now we're ready for the next task in the queue, which is our task that was created by our step timeout. And so we process that, and that is console log B. So our console output ends up being A, C, B. Okay. So let's go check that over in the code. And I'll comment out our example 1 that we had. And you can see example 2 here. We have our set timeout. We're just using 0 for our, basically that's the minimum time that you would wait until you fire this other action. So you're kind of like mimicking asynchronous behavior. Again, remember JavaScript is synchronous, so we're just mimicking asynchronous. We're not actually doing two things at once. Someone's not going and making our pizza. We're not processing that set timeout while we've put it in the queue. It's actually just waiting to be done. So it does get processed in kind of an order, just synchronous order. Okay, so I'm going to save this, and then I'm just going to clear out our console, and I'm going to click this. Oh, I need to refresh. Clear this out. I'll click it, and now you see A, C, B, just like we expect. Okay, let's go back to our drawing. Okay, and now you can see I've replaced the function 1 with we've replaced the set timeout in function 1 with a promise. Okay, so let's do what we did before. We fire off the button click and we get a task. The stack is empty, so we send over the task over to the stack and we start processing it. We run into console log A, got it. Uh-oh, now we have a promise. Okay, so with set timeout, we saw that that created another task that got added to the back of the queue. With promises, promises are special. They're actually something called a microtask. So let's step aside here and talk a little bit about microtasks. So microtasks came before promises. Promises just happen to be under the microtask label. But that's what the browser refers to them as. And microtasks kind of have their own special queue. And so when you fire off something into the JavaScript stack and it's processing and it hits a promise or a microtask, it sends it over to this like side queue. Who knows what it actually looks like, but just imagine kind of this side queue that's just for microtasks. And microtasks are never run until everything in the normal JavaScript stack is done processing. So let's say you have like 50 console outputs. Well, it's got to run all of those first, and then it will come back to the promise. right? So again, we're mimicking asynchronous behavior, though we know JavaScript is synchronous. We're literally just pushing these promises, these things that we need to process to kind of the back of the line. And so the microtask queue and the JavaScript stack together, those are still taking up processing power, and the event loop is not able to do things like re-render the DOM or render images or re-render the CSS DOM. And so it can still be blocking. Whereas with SetTimeout, because we created another task and we cleared the whole stack, the browser could sneak in maybe a DOM task, or it could sneak in rendering an image. So we'll see that kind of in play and how that affects things later on, but just kind of keep that in mind. Okay, so let's scroll up, and now we see our promise, and we're gonna put something in this new microtask kind of queue. Okay, and then let's go through, we see console log C, and we got it, so let's clear that JavaScript stack. And we know every time we clear the JavaScript stack, then we can go process microtasks. So we process the next microtask, which is our promise, which resolves immediately. We don't have to wait on anything. It's not going to make another API call or anything like that. So we resolve it immediately, and we get console log B. So we still see that same console output that we saw with SetTimeout. We get A, C, B, but we know behind the scenes, things kind of happen differently. Okay, so let's go back to the code and just double check that that actually processes like I told you it did. Okay, so I'm gonna comment out our example 2, and then I'm gonna uncomment example 3. And you can see now I have this promise that resolves immediately, and it console logs B. And I'm gonna refresh this guy. Let's click, and we see A, C, B. Okay, great. Okay, so we've seen how, and in the last couple of examples, how the SetTimeout and promises kind of were doing things different behind the scenes, but we still got the same console output. We still got that A, C, B. So we didn't really see any difference in functionality. At least it appeared to us that things weren't different. But we're going to change that up. We're going to now show how that process, how things are affected from the stack and the queue, and how promises are actually microtasks, and SetTimeout actually create a new task that goes into the queue, how those differences affect rendering. So what we're going to do is we're essentially going to try to block rendering. So remember that the event loop is just circling around, and it's picking up new tasks. And every time the JavaScript stack kind of processes a task, then it picks up the next one. Well, in between picking up those next tasks, like some of those things are going to be browser specific. So it's going to be things like rendering the DOM or an image. Now, one way to break that is to have an infinite loop. And so we're going to do that. Basically, what you're doing is you're making it so that the JavaScript stack is constantly busy. So we're going to do that here. We're just going to uncomment this while loop, which is an infinite loop, because true is always true. And you see I've got a GIF here of Macklemore. I'm just going to refresh, and then this is going to break. So now you can see that the page doesn't render, and I can't actually do anything. Okay, so we know that happens, and I'm not even going to show that in the drawing because we kind of get that understanding, and we're actually going to look more closely at SetTimeout promise, so we'll go back to the drawing. But to get out of this, I can't actually even refresh this page, so I'm going to uncomment this while true. I'm going to save it, and then I'm just going to open up another task or another window or tab, and now it works. Okay, so the next one we're going to look at is with a SetTimeout. And essentially what I'm doing, I'm firing off the event loop on a window reload, and loop gets called, and then I call SetTimeout, and it's calling itself again. So it's kind of like a continual loop, right? And notice I'm also console logging Meep here. So let's see what happens. Save this and refresh, and you can see it's still working. What's happening with Meep? Well, Meep is getting called very quickly. So you can see literally how many times that loop is getting called. And notice it's happening extremely fast. When we look at a promise later on, you'll notice that this Meep isn't getting called as fast. And that's kind of for a different conversation and kind of a different video. But it's important to know that like SetTimeout still allow images to render, and that's able to happen because we're slipping in, the browser is still able to slip in task into that queue. Okay, and we'll go back to the drawing here in a bit, but I do want to show you now what it looks like with a promise. We'll pause this, and I'm going to uncomment this, and we're going to refresh. I'll clear this guy out. All right, so you can see that it broke. It got part of the image in, and then MEEP is still getting called, but it's getting called a lot slower. So let's go ahead and look at a drawing and see what's kind of going on behind the scenes. Okay, so with SetTimeout, I've just got the function in here. You can see that when we load the browser, we call loop. It's a task. We fire it over to the JavaScript stack. And then we hit SetTimeout. We create a new task that goes over into the queue, and we process MEEP. Boop, clear the stack, and then we can go get another task. And this happens over and over and over again. The big difference here is that there is a period in which the stack is cleared, the JavaScript stack is cleared, and we're actually fetching the next task from the queue. So because of that break, because we have a period in which the JavaScript stack is cleared, the browser can insert and do things like render an image or a GIF. Okay, let's just check this out now with a promise, where we saw in our example, the promise actually broke kind of the page. MEEP was still getting called, but the thing there was nothing happening on the page. The browser couldn't do anything. Okay, so let's check this out. All right, so we fire off loop on window load. We hit a promise, and what do we create? We create a micro task queue. Okay, so we know micro tasks get processed after everything in the JavaScript stack is cleared. So we hit console log MEEP, we send that to the console, we clear it, and then we go to our micro task. And that just calls itself again, so it creates another micro task, another micro task, another micro task, and also MEEP, right? So it's constantly doing this thing. And if you remember, the browser still can't insert anything until both the JavaScript stack and the micro tasks are cleared. So it's not able to insert anything like re-render the DOM or render an image. And so MEEP is still getting called, as we saw, but nothing else is happening because the browser can't insert anything into the event loop. It's totally full. So that's kind of the big difference between promises and SetTimeout. Promises also are native JavaScript. And remember, SetTimeout is not. It's an API that we're hitting. And their differences cause the rendering of page differences, right? And that's kind of the big takeaway. For this last exercise, I'm not going to draw anything out. This is kind of like a bit of a mind bender. And this I kind of augmented this off of some of the quizzes that Jake Archibald did who's the Google Chrome advocate. And I just want you to kind of think through these kind of get your mind thinking about more complex situations and kind of how promises, SetTimeout, and those type of things all kind of work together. So you can see in the HTML down here, I just have a button with an ID, a button. And then up here, I'm grabbing that button, assigning it to button, and then I'm adding event listeners to it. And it's happening simultaneously, right? So the moment that I click the button, an event listener click has been added to it. So the button is going to fire off two things. And what's important to kind of keep in mind is that because I'm doing this through HTML and then JavaScript, so I'm adding an event listener onto an HTML element, and it's kind of structured this way, it's going to create two different tasks. So I'm going to have a task for when this guy happens and one for when this guy happens. Now, if we look at this first task, we can see I hit a promise, so we know we'll throw that into the micro task queue and kind of put that behind everything. With SetTimeout, we're going to totally take it out of the task, and we're going to throw it into we're going to take it out of the stack and throw it in as a task into the queue, right? So it just like totally, it gets even farther behind the promise, right? And then we do console log A. So we're fairly certain console log A is going to happen first, but then let's think through this. Like, do I hit console log B? Like, how does this work? Well, remember again, these are two different tasks. So I won't hit this task until I complete this whole guy, right? So let's see how this plays out. All right, click me. All right, console log A, my promise 1. And then I don't even get to my SetTimeout because that task that was created by the SetTimeout is behind the task that came in before it, which was right here. So I go B and then promise 2, and then I get to my set timeouts. Okay, and then to kind of throw you through a loop, and this one's really hard to kind of grasp, but now what I'm going to do is I'm going to have JavaScript actually assign the click. It's going to take care of the click. And when you fire off a click from JavaScript, that's one task, and everything underneath it is going to be processed by the JavaScript stack. So you're not doing 2 tasks. It's all bubbled up underneath this click, right? And so now how is that going to play out? And all I actually have to do here is just, I'll clear this out and I'm going to refresh. And what you can see is I go A, B, because again, this is all one task. So I come here, I go A, and then I still have to keep going. I don't go and I resolve my promise. I go and I resolve this B. And then I go to my promises, because I go, once the JavaScript stack is clear, then I go to my micro tasks, hit my promises, and then the whole stack is cleared. And then I go to my 2 new tasks that were created by my set timeout. Okay, so hopefully this has been a helpful walkthrough and you have a better understanding of how the event loop works.